Okay, one final, I guess, conceptual video of the coefficient of restitution, E. Just a reminder, I did speak about it in the previous video, but what is it? It is simply the ratio of the relative velocities of the particles' separation just after impact to the relative velocity of the particles' approach just before impact. Okay, so remember, E is the ratio, it's the final velocity of B and minus the final velocity of A divided by the initial velocity of A minus the initial velocity of B. Okay, so notice that in the top here it's B minus A, in the bottom it's A minus B. Okay, so just take note of that. All right. Now, I'd like to just mention this. This is quite helpful. I did mention it earlier, but we've got two extremes. We've got an elastic impact. This is where we lose no energy. No energy lost. Okay, and the example is, if you go and look at example 15.5, remember when those two bumper cars attacked each other? Then it says specifically no energy is lost. What does that mean? Well, it means this. R dt divided by the integral of P dt is 1. It means that your restitution impulse is equal to your deformation impulse. But we know that in real life that can't happen. But sometimes you can approximate your E to be 1. Okay? Yeah, it also means that this ratio of velocities in the numerator equals this difference in velocities in the numerator equals the difference in velocities in the denominator. Okay. Then the other extreme is E equals 0. And this is basically where you have two particles attacking each other, colliding with each other, and sticking together, right? Or coupling. They're coupled together. So the example is, you can go back and check out example 15.4, where you had the two trains coupling together. So this is called an inelastic or plastic impact. Okay, E equals 0. So this means there is no restitution impulse. This numerator is 0. Okay, there's no restitution impulse. They stick together. Okay, so the one helpful thing about knowing the E value, okay, remember that it's VB2 minus VA2 over VA1 minus VB1. If you use this in conjunction with other equations like the conservation of momentum, etc., is that you're able to then find what your energy loss was during the collision. Okay? We know that if E equals 1, there's no energy lost. However, if E is less than 1, then we have lost energy. We've lost energy. And where do we lose it? We lose it to sound energy, thermal energy, right? The energy is transformed into those kinds of energy, and we can't use it any longer. We've lost that energy. Okay? And we'll do an example where we will actually calculate how much energy we lose. However, when E is 0, that is where we have the maximum energy lost. Okay? It doesn't mean you lose all the energy. It means it's the maximum energy that you can lose in that collision. Okay? So just to recap that whenever there is a collision, okay, or impact, momentum, what happens to momentum, guys? Momentum is, momentum. Momentum is conserved, always. Because if two particles collide, those internal forces cancel out, momentum is conserved. However, energy And this is, energy is not necessarily conserved. Not necessarily conserved. Okay? It's only conserved in this case, E equals 1. But if your coefficient of restitution is not 1, then we have energy loss. We have energy loss. And we need to sometimes calculate that. Okay? I hope you're getting the picture.